Quadratic inequalities. We're going to look at two different ways of solving these. First, we'll look at solving them algebraically. For our example, we will look at x squared minus 7x minus 30 is greater than 0. Our first step is to make sure all terms are on one side with a 0 on the other. We already have that, so we do not need to follow through with this step right now, but in some inequalities you will. So we already have x squared minus 7x minus 30 is greater than 0. Second, factor the left-hand side. LHS is left-hand side. So I set up my two sets of parentheses with x, and I'm looking for factors of negative 30 that add up to negative 7, and they will be negative 10 and positive 3. So this factors to x minus 10 times x plus 3, and that product is greater than 0. The product is positive, it's greater than 0, so either both factors are positive or both factors are negative. So x minus 10 is greater than 0 and x plus 3 is greater than 0, or x minus 10 is less than 0 and x plus 3 is less than 0. So either both factors are positive, greater than 0, or both factors are negative, less than 0. If we had the other case where the product had been negative or less than 0, then one factor would need to be positive while the other factor is negative. We would have to look at both combinations of pairs so that we would have x minus 10 is greater than 0 and x plus 3 is less than 0, or x minus 10 is less than 0 and x plus 3 is greater than 0. We don't have the case where the product is negative, so I'm going to erase this, and we will solve the pairs x minus 10 greater than 0 and x plus 3 greater than 0, or x minus 10 less than 0 and x plus 3 less than 0. So, step 4, let's solve those inequalities, getting x by itself. So in the first pair, we have x minus 10 greater than 0 and x plus 3 greater than 0. Let's add 10 to both sides. So I have x is greater than 10. Let's subtract 3, and we get x is greater than negative 3. So x is greater than 10 and x is greater than negative 3. Where are both of these true? They are both true when x is greater than 10, because all values of x that are greater than 10 are also greater than negative 3. Okay, let's look at the other pair. X minus 10 is less than 0 and x plus 3 is less than 0. Add 10 to both sides. X is less than 10. And let's subtract 3 from both sides. X is less than negative 3. So we're looking at x is less than 10 and x is less than negative 3. Because I'm looking at both of them, where are they both true? They are both true when x is less than negative 3. Because all values of x that are less than negative 3 are also less than 10. Okay, now we will combine the pair of inequalities into one compound inequality. So I've got x is greater than 10, or x is less than negative 3. That's my compound inequality. If I want to write this in interval notation, start with where we have the smaller values. X is less than negative 3. That would become negative infinity to negative 3, or is the U sign symbol. And then x is greater than 10 is from 10 to infinity. Okay, the other way we're going to explore this example is by solving graphically. So we'll use the same example. x squared minus 7x minus 30 is greater than 0. Our first step, we're going to factor and graph the inequality. So we've already factored this. We set up our parentheses with our x's. We looked for factors of negative 30 that added up to negative 7. We found negative 10, positive 3. So x minus 10 times x plus 3 is greater than 0. Okay, we've got zeros at 10 and negative 3. Our graph looks like this. It goes way down below on the y-axis. I just didn't want to draw it to scale, but where it crosses the x-axis is to scale. Okay, if we have a greater than 0, which we do, find where the graph is above the x-axis. If we had the other case where we were solving an inequality where it's less than 0, find where the graph is below the x-axis. So we are looking for where the graph is above the x-axis. That's where the heavy shading is here. And we can actually find these points. If we couldn't factor our inequality, we could find these zeros on the calculator by using second trace 0, which is option number 2, to find those values. And so this part of the graph is where x is less than negative 3. That's above the x-axis. And the other part of the graph is where x is greater than 10. And this is the same solution that we got solving algebraically.